Alright, this video is going to go through how to do the 2017 axonometric projection question higher level. The question tells us the axonometric axis required for the isometric projection of an exercise treadmill are shown. The elevation plan and a 3D graphic of the treadmill are also shown. Part A is the part of the question that we're going to do rather than part B, where we draw the axonometric axis which is shown in the pictures. So for part 1, we draw the axonometric axis as shown, so basically the crow's foot. Part 2, draw the given elevation inclined at 15 degrees as shown. Part 3, draw the given plan inclined at 45 degrees as shown. And then Part 4, draw the completed axonometric projection of the treadmill, basically the 3D shape that occurs in the middle when all points are taken up and across. So to start off this question, I'm going to draw out my crow's foot. And what I'm going to do is I'm going to position that roughly about this height roughly here. I should have enough room on the page. Just take a line across, and I need to come in about this much here. It's not that wide, so that's going to be my center point. From the question you can kind of see that everything is going to be kind of pushed to the left hand side of the page because you have your elevation up here and your plan underneath. And we just draw our crow's foot as normal. So we have our 30-degree line going this way, our 30-degree line going this way, and we have our vertical line going up. There's our crow's foot. After that, we extend our 30-degree line out to the right to find the position of where our elevation is going to be, and our vertical line will extend down to show where the plan is going to be. So for the plan, I'm going to position it roughly about here. That's going to be my top point, and then using my 45-degree set squares, I'm going to go out 45 degrees this way, 45 degrees this way. From the question I can see that the width of the plan is going to be 64 mm. I can take that 45-degree line down here and just extend this one, and then the total length is going to be 50 mm out, and then 76 after that, so again it's a total of 126. And that box there now is going to be my box that my plan will fit inside. So now I'm going to draw a box that will actually hold my elevation in. So what I'm going to do is come out maybe about 100 mm from there. Should have enough space. And this is inclined at 15 degrees. So what I do is I draw a vertical line there. There's my center point. Get my protractor, put it aside like this, and measure my 15 degrees there. And this edge here, there's my point there coming out, there's my 15-degree line there, and now I have to go perpendicular to that line there to actually get my baseline of my elevation. And that line is just drawn out like that. Just use my other set square, just extend it the rest of the way. So it's 126 here. So that means the length of this has to be 126 as well. That will take me out to that point. Now I just use sliding set squares again to get my line going up here. And then total height for my question goes up 30 first, then 35, and then 25 left over at the top. There's my 30, making sure that's my 35. And then finally my 25 at the very top there. And then I can just extend this line here. Now if yours goes slightly off the page up here, it doesn't really matter because the treadmill is going to be going kind of down here and then across. All this area will not be used at all, but just for my question I actually managed to just fit on the page. After that then I'm going to start drawing in my elevation. So I have my 30 there as a radius 15 semicircle at the end. Just take that across there, measure across 15 to find the center point. What I'll do is I'll draw my lines in there so I can see where the top and the bottom of the semicircle are going to touch. So there's my semicircle drawn in. After I'm going to draw my radius 100, which occurs along this line here and is rotated around to hit the base. So I'm told it's 100 mil in from this edge here. I'll stretch my compass out the 100 distance, and it just rotates around like that and hits the base at that point there. From that now it can be extended. Sit there heavy. So then looking at my plan, I get a 50 mil distance. I can step out here in my elevation because not all the information given to you for the elevation is actually given, so you need to actually use your plan distances to actually complete your elevation. So the 50 mil in your plan is going to be used in your elevation as well. And then what I can do is I can measure in 16 here, take that across heavy. I'm told that's a slope of 30 degrees. So what I'll do is I'll use my set square like this here, then put my 30 degree on top to give me my 30 degree slope, and that slope goes out to hit my 50 mil line there, and that's what gives me this little height here. Told I go out 12 here, and that gives me my dash line going down here that I can't actually see. And then I go further 8 after that then. And that line can then run in all the way to there. So the 12 and the 8 give me a total of 20. And that line then can go all the way down to the ground there. And I can close off the top part here. Finish off the back part. And that is my elevation now complete. So I can now use some of these widths from my elevation to actually help me out in my plan. So for example, we're not actually given the distance from here to the bottom of that curved surface there, so that point in there, so I can now use that and mark it off for my plan. I can just stretch my distance out to here, mark this off, stretch my compass out to here, mark this off, and this just saves me having to measure them over and over again using my set squares. Take that distance there, mark it off. I also have my top one here I can mark off. Now what I can do is I can start taking these lines across at 45 degrees and begin drawing in my plan. So with the plan, the back of it is the full 64 across. That 64 goes all the way down to where the 50 is, which is this point here. and this line here. Then what I'm told is I have a central axis running through here the whole way. If it's 64 wide, I take 32. And I'm told that the width of this part of the treadmill here is actually 50. So I need to do is step out 25 each side. There and there. And I can just take this in lightly for now because I have to figure out where it's going to stop. There's also another width applied here. Total width of 40, so I do is I step out 20 each side. And that width there is where the handles are going to go in each side on the actual treadmill, so this part up here. And that comes in the 12mm distance, which should be just there. There. That goes across heavy. I can then see that I can take this line in heavy up to here. It then goes dashed up to that surface there. So basically we're talking about this line here. So heavy all the way into there and dashed the rest of the way there. And then that line is going to be dashed all the way across. The line just behind that is also in dashed as well. And this line in heavy here is the actual surface there. So that line you can see, everything else is hidden detail then. And then I need to draw my front line here. And that completes my plan. So now I need to do is start taking up my points and actually drawing in my 3D view in the center of the page here. So what I start with doing is the actual front, the running part of the treadmill. So what I'll do is I'll take up my box kind of shape here. So what I need to do is for this part measure in 15. There's when we're only plotting points along here and we divide our semicircle up into a number of equal parts. So I'm just going to take up the rectangular part that we need to see. So I need this edge here, this edge here. What I'll do is I'll bring in endpoints now, so that line there, and this line here. So you can see that's my actual outline in 3D. That'll be going back at 30 degrees on this one and this one. And where they stop is where this edge comes through here, and the very bottom one here. So you can see it stops here and there. And just showing in the actual question, that's where it actually stops in plan. If I line that up, you'll see that it actually meets that point as well. What I can do then is I can start drawing this bottom part in heavy, because I'm going to see all of this. Just to show what the back corner here actually lines up with that corner there. So that point there is that one, and they all line up. And now all I'm missing on the bottom part of my treadmill is just the actual curve on the front. So what you need to do is, it's easier to divide up. You can use your 30/60 set square, or you can take your radius and step it from this point here. So I'm taking it from the top, go around to this point here, step it out there, step it out there, and then go from that corner there, step it out there, and that divides up also into 30/60s. I'll label 0, 1, 2, 3, 4, 5 and 6, and make sure clearly I can see where my points are. After that then you're going to need to have a piece of paper. And what I'm going to use is I'm going to use this piece of paper to actually mark off the widths of my points and actually use them to apply to my plan. So what I'll do is I'll line it up here. I'll take up 2 and 4, 1 and 5, and 0 and 6 already there. And I can get this piece of paper and mark off 0, 1, 2, and where the 3 sticks out. So in this one I have 0 and 6. This one I have 1 and 5. Here I have 2 and 4, and this one right here is 3. What I then do is I take that to my plan and I apply it to it. So you can see the distances are the exact same between 3 and 0. I just have to mark in the position of 1 and 5 and 2 and 4. And then take that across. So that's a fast way of actually taking your points instead of having to measure them. You just mark them off on a piece of paper or just roll a piece of masking tape or anything in the exam. So here I'm going to have 0 and 6. This one here is 1 and 5, 2 and 4, and the bottom one is 3, and I'll mark on the opposite side as well. 2, 4, 1, 5, and 0 and 6. What I can start to do now is take up these points and find out where they are in my 3D view. So you can see 0 and 6 already done for us. See 6 there, 0 there, 0 there, and 6 there. What I'll do now is I'll take up points 1 and 5. So in the front part here, along that line are points 1 and 5. If I go up to this view here, taking in 30 degrees, there's point 1 there. There's point 5 there. I'll repeat it now for 2 and 4, and then finally I'll repeat it for 3 then. So 2 is going to go there. 4 actually is on the same line as 5, so 4 is going to go here. And then finally I'll take in 3. So 3 will go in there. 3 comes straight up from here. Get point 3. What I can now do is I can draw in my freehand curve. I'm just drawing in all lightly for now. And then I can do the same on the back. So I'll take up 1 and 5. 1's already taken in here, there's 1. 5 is already taken in, it's here. 2 and 4 taken up, there's point 2 there. Point 4 should be out here. And finally 3 is on that point there. What I'll do is I'll just draw the curve in again, nice and neatly, like that. And now we're going to take in our tangent edge. So it's important with our tangent edge that we always go perpendicular to any tangent point when you're drawing your normal. So because these lines are all going at 30 degrees, from our center point our tangent is going to be at 60 degrees. Our tangent line there, that point there is the exact point where we're going to have our edge, where we can't see the rest of this part of the circle here. It's going to be hidden. So when I take in that line there, it touches curve there and there, and now I can actually draw in heavy. My curve going around here, the curve going the rest of the way around there. That's my actual tangent edge now drawn in, and that completes the actual running part of the treadmill now. So just to highlight one of the points for you, just highlight point 2 there. So I would have taken 2 in, and 2 would have stopped where 2 came up the back part of the curve there, for example. So that's how I would have found all of my points. taking my point up and taking it across in there. Now I'm going to focus on drawing the rest of the actual treadmill. So just carrying on like I did before. So I'm going to start with the top. I'm going to focus on this section here. So just going to take in these 2 points here. They occur along the back there. Now I have that back surface there. And that runs all the way back to where this corner is here. That'll be coming back in at 30 degrees to hit this point here. Just to show once again, for example, there's my corresponding one. I can take that up and I show it meets it there. And this one I can take up to show that it meets it there as well. And now I can draw that part in heavy. And then I'm going to draw the slope and outline here. So that's going to go in 30 degrees this way here. Where that slope stops, goes all the way to my outside edge here. So follow it in where it meets it. There. So I can connect that point to there. And then the front one, that slope line goes all the way to there, so following it in, following it up, and then connect these two together, and they're going to be parallel with each other. After that I'm going to draw the front little handle parts. They're going to be little squares or rectangles, so that'll be going down to there and there, and the thickness of them go into here and here, so you can just see now when I draw it in. There's one of them there. There's the other one. And that will go back in at 30 degrees, and that will go all the way back in to where the handle goes back to actually that point there. So that will go into there. And the height that will go up, so at that point there, same as this one, there's my height. Get my height in. I can see that that is going to go up to that edge there. And then these two can connect together. And you notice that these surfaces are still running parallel to each other. And I'm going to have my slope surface coming up here as well. So what I can do is I can extend out my line here. Take that edge up to meet it. Draw this in as well. Then go across there. Now we'll go heavy across to there. I'll also have a line coming down here from the back corner of where the treadmill extends out the side. So in the front you'll see there's this line here where it comes out here, and that point is located out here. So you can see that point there is this point. It comes out to here, and I extend that up, give you this outer edge here. So that'll be going out to there, and that will be going straight up, all the way up until this handle goes back at 30 degrees to meet it. Just so you can see, it's basically this edge here. See, they just actually match up perfectly there. So you don't take all lines actually in and across. You can take some of them and you start to figure out where the actual shape is starting to appear. But just to check for yourself, you can always extend the lines out just to see, to make sure you're going right, that you haven't taken a line too far out or anything. After that then, I'm going to be going back out to this point here. So I can take that out to there. This line will go 30 degrees back to meet it. And now what I have between here and here is going to be this freehand curve as well. So what I just do is just take random points. So for example, these lines here are already taken back in 30 degrees. So what I can do is I can mark, say, that point and just label it A, B, C, and the bottom one D. Save me having to take in more lines and get confused. I can actually use lines I already have. And I do the exact same thing as I would have done with the semicircle. I'll just drop those points down. Get that piece of paper I had, and on the back of it, mark off D, C, B, and A. Go to my plan view, so you can see their D lines up with that dashed line going across. C is going to be there, B is going to be there, and they have that A, B, C, and D. D is there. Get my 45 degree line, take them across so I can find where A, B, C, and D are on the opposite side. And it's the exact same process again. A comes in there, A goes up there, D comes in here, and D, you can see anyway, I've already had it drawn, D will come into that point there. And then all I have to do is extend up B there, find where B is, it was on this line here, extend it out, I have B here, and the exact same for C. Take C up, and C was actually this line I would have originally drawn out. And there's C there. And all I need to do then is nice and neatly draw a freehand curve to complete the back part. And all I'm missing now is my back corner that's going to be taken out on the far side. So it's occurring along this line here. That edge there is going to be just out here. So I'm going to have that line coming up there. And that will complete the question.